Thanks very much, and it's a pleasure to speak at this meeting, and also pleasure for GNS to sponsor this meeting to some extent. It was noted earlier that GNS is the only CRI that is not in Christchurch, but I can assure you that GNS and our partners are very much in Christchurch and will be here for the foreseeable future. That's probably quite some time. Today I was asked to speak about things subterranean, but I would like to say also that many of our relationships here in Christchurch go far beyond earthquakes or GeoNet or some of the earthquake probabilities that are still coming out, and in fact it's a pleasure here at our table here. We have people from GNS and Treasury and Sarah, and we're engaged with very many parts of the recovery process in Christchurch to do with not only seismology but also some of the geotechnical issues to do, and with CCDU, with Ngaitahu and a lot of social science work that's going on, and the wellbeing surveys with Sarah in collaboration with Sarah. So our research platform, or our gamut across the natural hazards research platform, extends far beyond the earthquake occurrences themselves, but that is my topic today. So just trying to put a context to some of the next sessions. Where are we up to? I should hopefully, right. Just a little bit of the context. There on the left you'll see that we've got, as a proxy for why are there earthquakes in Canterbury and where are there else earthquakes throughout New Zealand, the red stuff, and this is coming from the New Zealand network of GPS stations, and it tells us where the strain is accumulating around the country. You can see that in Christchurch or in Canterbury, it's on the it's not so warm colours. The really hot colours are the areas where there's more strain accumulating. It coincides very well with where are the earthquakes occurring. Christchurch is lower, but it's not zero. So earthquakes have always been part of the Canterbury environment, but it's never had such a direct hit certainly in the historical period. The reasons for that are on the right. The whole plate boundary setting between on the left, we're part of Australia in some ways still, and on the other side, the Pacific plate that goes all the way across to the California and South America, and the Pacific Ring of Fire. The Alpine Fault there that's shown, that's got about 100 times faster movement rate than the Greendale Fault that caused the September earthquake. So we're a huge gradient from the Southern Alps and the Alpine Fault down here through through Canterbury, but rare events have to happen sometime. And really that's the bottom line, or the take-home message. Rare events have to happen sometime, and very unfortunately it has chosen September, but particularly February and June of 2011 for those rare events to happen. So very much a wrong time, wrong place message. This is the, excuse me, the month of September 2010. You can see there the Greendale Fault in the big red line, but all of the aftershocks within the month of September of 2010, that extended across a little bit into beneath Lyttelton. And remember, now I'm losing some of the dates way back then, approximately a week after the 4th of September, there was the substantial aftershock over there, which it shook us up. I was in a hotel, and it certainly shook us up at breakfast time. The other dash lines there around Christchurch are what we know now are where the future faults are that were going to rupture in February and June. So this is what we knew from the month of September. It's quite distributed, and I'll come to, they're actually, it gave us a clue immediately, but we didn't really recognise all of the features to start with. So here we are out at Highfield Road on the Greendale Fault, as much as 4.5 metres of movement of the ground. You can see the big offset of Highfield Road still as you go out there, just out west of Rolleston. a lot of work was done on the fault line and we understood it. It was giving us a little glimpse of what's happening in the subterranean, but only a very small glimpse. Otherwise, we're looking at the seismicity patterns. That's the seismicity that had developed up until the 13th of February of 2011, starting back in September. We'd had a Boxing Day swarm little events as well, very much under the city, but there was quite a large distribution of aftershocks extending north of the epicentre of September up towards Darfield, out to the west, a little bit south, some near the city, but not a huge number. And based on the statistics at that stage, the chances of a magnitude 6 plus in 1 year within that aftershock region was set at something like 25%, plus or minus some very large uncertainties, of course, which often don't get carried through the media, I would say. That 25% somewhere within the aftershock region, that would be the expected likelihood of a 6 plus. And you can see in terms of understanding the subterranean, they seem to be in clusters and they seem to have all sorts of different orientations. There's that very north-south sort of oriented cluster, very much an east-west cluster as well, and some other directions. This was beginning to give us clues about what is the fault pattern down there at 6, 8 and 10 kilometres below us that, of course, we can't see. So we're trying to look at these earthquake occurrences as a proxy for how is the Earth working in that subterranean space. So that number was widely communicated, but what did it mean? We didn't develop any scenarios of what would happen if a magnitude 6 was here or here or here, and a big lesson learned from us, a possibility would have been to develop a magnitude 6 scenario as though it would be in the city. Now, that's sort of a very pessimistic view. A much more optimistic view was that future magnitude 6 would be far away from the city, but I think with hindsight that would have been a better communication than just saying a magnitude, because we've run into the problem of how come a smaller earthquake can do so much more damage. Well, that's because we understand that as scientists, but our communications maybe sometimes haven't been as direct or as well structured such that we could convey that to all of the people that need to know. So wise with a little bit wiser, well, hopefully a lot wiser with hindsight. And of course, there's February and the aftershocks, February 22nd and the aftershocks around that for the next month. Very much worst case scenario, very much in the city. So yeah, the future magnitude 6 plus was the worst case scenario. What do we know about those now? And this is a pretty complicated diagram, but it's trying to say that if you look down in the earth, and we can do that from lots of different measurement ways now, we can understand where the earthquake started. That's the red patch on that February 22nd fault. We can understand where it started, the fact that it was actually very shallow, only 2, 4, 6 kilometres below surface, and which direction did the fault move in. So that fault was essentially a little bit north of east, really complicated because in June it had the earthquake ruptured a fault which had the almost at right angles to that. We're beginning to see a little bit of this interaction between faults with different orientations, quite small, compact faults for which we've got no evidence for at the ground surface, none whatsoever. Post some of this work, we've been to look at the seismic section, you know, the sort of oil company type approaches to looking at all of the layers in the subsurface by setting off explosions and measuring them on seismographs. These faults you can barely see even in layers that are several million years old. These are exceptionally low slip, very, very rare events. There's other reasons, but then also another part of this is that there are reasons for very strong shaking, some of the highest recorded shaking anywhere in the world, certainly in New Zealand. The proximity of the tip of the fault, the fact that we've got a layer of volcanic rocks which are really hard and ring like a drum, and then that transmits that energy into these weak, soft layers with soft soils with high water tables. So we've got on the Port Hills very steep, some steep ridges where if you put the energy in from the bottom, it amplifies it to the ridge crest. So we're seeing a lot of that as you go around some of the hillside suburbs. So that's a really amplification opportunity, and we've seen it with all of those greater than the force of gravity accelerations on the Port Hills, literally throwing everything into the air. And on the Christchurch, on the city side, a lot of these basin effects, which often amplify some of the ground shaking as well, and the liquefaction issues. So we understand it, but again, we'd come back to the point that other earthquakes coming from other directions or other types of earthquakes that might be experienced in Christchurch will not have these sorts of really amplifying situations. So if we sum all of that up now, and some of this has come from work that's been done post the earthquake, if we look in the top right-hand one there, offshore it's much easier because of the surveying methods, much easier to see a picture of what's happening. Much more difficult to do the same sorts of work on land. We can see that there's a lot of east-west oriented fault lines. Those were formed more than 100 million years ago in a totally different arrangement of the plate boundary. But now, the Chatham Rise is being, because of the plate boundary situation, the Chatham Rise is being pushed up against the Southern Alps. And so these faults are being reactivated in a different direction with different stresses, and it's reactivating some of these very old faults, and they're behaving a little bit differently. They're not very well oriented to taking up the strain, and so they're breaking in lots of bits and pieces. They're breaking with lots of different orientations, and they're quite small little faults. So we're quite confident about the maximum size of earthquake that could occur in the region, but they're very difficult to see because they're very small structures, and they're down there at 10 kilometres or so. There was a few, in the bottom left you'll see that there was a few indications of these. We've known about the fault to the north of Kaiapoi for some time, and also down to the south there on the way towards Ashburton. There are a number of these east-west structures that do deform the ground surface, so we can see them at the surface as just a little window into a lot more extensive fault pattern. But in the right-hand corner there, you see that Alpine fault, the mountains are where lots of things are happening, the plains are where not very much is happening, and we're out here in the nether region of this plate boundary. But there are faults here, there are a little bit of strain, but it is about 1% of what we expect on the Alpine fault in the long term average. So that's the total seismicity pattern at the moment. You can get the feeling that there's lots of pieces, lots of clusters with all sorts of different trends, including the December 22nd and following events. So basically the 2012 stuff has been predominantly offshore, with much more of a northeast trend than the east-west trend we were seeing in either September or in June. So complicated pattern. Overall, that's the number as we truck through from 2010. September 2010 on the left through to January or February of 2013 on the right, and the magnitudes of the earthquakes on the left-hand scale, you can see that more than anything else, they're getting fewer. So that, and everybody living here will know that very, very well, that they are becoming rather more rare events now rather than several times per day. There has been these sort of rejuvenation things that coincide with much more increased activity, so they die away very quickly, and then there's been this rejuvenation. Firstly, you see there in February of 2011, and then June 2011, and then December of 2011. 2012, the whole year, was relatively quiet and relatively diminishing, but this is still much more seismicity around than there was prior to this whole episode starting in September. So all of those ideas have fed through into revisions to building codes, It underpins some of the red zoning decisions about, well, we still expect further earthquakes in the next 25 or 50 years, and will there be further liquefaction? Yes, in some of the worst areas. Feeds into building and housings, requirements around foundations. So all of the stuff has been fed upwards and sideways into some of those recovery processes. Now, I won't go into that. Overall, that's saying that by now, in a number of different ways, it's not gospel, it's just a model, it's just statistics, but we've experienced roughly the right number of magnitude 5 earthquakes that you would expect coming from that initial magnitude 7. We're somewhere, but those dashed lines are some uncertainty bounds, we're somewhere in the right space, but with very large uncertainty. So this is not the gospel, this is not saying it's over, but it is saying on average it's got back, so the number of magnitude 5s that we've had is something like the right sort of number. Now, why is there so much liquefaction in eastern Christchurch? Well, that's because when you look on there in those numbers, this is the historical atlas of New Zealand from 1997, so it's not even the primary source of the data. It had even got into the historical atlas of New Zealand that the area was sea until really recently. So there's lots of very weak, very soft sediments, all with a very high water table. And those lines there tell you where the coastline was, starting around 8,000 years in the middle there as sea level rose after the last glaciation, and it reached its inland extent at 6,500 years around about the area of the airport. So that means from the coast going inland there's this big triangular bit full of estuarine sediments and mud and low gradient or low these fine-grained alluvial sediments, and they're really thick near the coast and they thin going inland, and then they interfinger with a whole bunch of gravel. So that's really well known. That's why there's liquefaction. It is no surprise whatever. But we do know now, and this is coming down to the CBD, we do know a lot about the ground under Christchurch now, and that provides the confidence that we know about the ground, therefore you can rebuild because you know the ground conditions. You can build in the CBD. We know that there's very strong foundation conditions down there at about 20 metres, 22 metres, over on the west side of the CBD, getting slightly deeper as you go towards the southeast. In between, that yellow stuff is the potentially liquefiable. There's a shallow gravel layer coming through from Hagley Park into the CBD. This has all played into some of the work or the assistance to CCDU in terms of the central city plan. The city is eminently rebuildable, either high-rise or low-rise. Take your choice. The foundation conditions are very well known. Thank you. A little bit of a subterranean run-through. Thanks very much.